Hey everyone, so today we'll be looking at 48 rotate image. Um, so I've already solved this question and this is one of the most important question. As you can see, a lot of companies like to ask this question and let's do it. So I've already solved it. Hopefully I don't have to look at the solution. If I had to look at the solution, then I don't mind. Okay. So at least I'll give it a try. So let's start the timer. You are given an n into n 2D matrix representing an image. Rotate the image by 90-degree clockwise. You have to rotate the image in place, which means you have to modify the input 2D matrix directly. Do not allocate another 2D matrix and do the rotation. Got it. Um, okay, so it's all about swapping uh, the numbers. So all we have to do is we have this array and we need to convert this array to something like this. So our this guy went here, our this guy went here, this guy went up here, and this guy went up here. So that's what clockwise we have to rotate, right? 90 degrees. That's what they are telling us to do. So what we can do is, for this particular question, is that okay, so what can I do this about this guy? So I will look at this, look at the question, and what I see is that I need to somehow swap this onto this position, then move this to this position, move 3 to this position. What about 1? Like I don't remember what 1. Then move 6 to this position. Oh, wait a minute. Wait a minute, this is not how it's going to work. So I transfer this 7 here, then this 1 is stored somewhere here, then 1 should go to this, then 3 should go to this, and 9 should go to this. So 9, 7, 1 will come here. I'll rub this guys out and then fill it with 3, rub this, fill it with 9. Okay, after doing this, okay, so I need to have a top. I think I need to have a top, a left, a row, sorry, a row, not a row, but a right, and a bottom boundaries for making the shift happen. How would I 0 0 1 2 0 1 2, so it's n into n, right? um, so what we'll do is we will start from, let's say, 1. If we start from 1, then uh, mm, okay, let's do one thing. Let's create a dummy variable which will store value of 1, value of 0 here, which would be 1. We'll start with matrix of top, which will be 0 0, and Top of, how will I increment top with, do I have to keep a left, top of left? Well, so I need to first matrix. I was thinking of swapping matrix of bottom of left with this guy, top left, and then we need to somehow take this value matrix, or take this dummy value and put this into, I'm this is just not making sense for me at this point of time. Let's see a tutorial. I'm really sorry. My rotate group of 4 cells. I know that, buddy, but how can I rotate? And so we can iterate over each group of 4 cells and rotate them. Here is visual. Okay, got it. So looks like I need to still watch the solution and you know see how I can do this. And whenever I start the solution video, my network really lags, so sorry about that.
Hey everyone, welcome back, and let's write some more neat code today. We're given an n by n matrix, so this time it's a square matrix for sure, representing some image, and we want to rotate that image by 90 degrees clockwise. And we are required to do this in place, so we cannot allocate more memory. We can't just make a copy of the matrix and rotate it like that. So the challenge here is definitely doing it in place. You can see that they had a original matrix like this. What they did is they took the 1 and put it over here, so 90 degrees. Basically what they did is took this entire first row and moved it into the rightmost column, right? And so they did that by moving this over here, moving this 2 over here, moving the 3 over here. And so the problem is when you're moving this 1 over here, you have to save the 3 temporarily, right? So you can save the 3, or once you move this 1 over here, you can take the 3, save it, and move it over here. And we know that this entire right column is going to actually be put in the bottom row. So what is actually going on is this 9 is actually being moved over here, right? That's where it ended up in the result. And then this 7 is being rotated over here. So that's where the 7 ends up. The 1 ends up over here, the 3 ends up over here, the 9 ended up over here. So these 4, let's say, have been rotated so far. So now we don't have to touch them. But you can see there's a little bit left in the outer layer. So let's just worry about the outer layer so far. We don't have to worry about the 5, but in the result, we know that the 5 actually doesn't move. You know, you rotate it. But what about this 4? Now, it's basically the same thing that we did over here, right? We are rotating this. So basically, we can think of it as being in the top left, right? The original square we were rotating was like this. Now the square we're rotating is like this. It's still technically a square, you know, if you turn your head a little bit. But this is what we're doing. We're rotating this. So this 4 is, of course, going to be moved over here to this 2. And before we get rid of the 2, we want to save it and move it over here to the 6. And so in the original, we have a 2 over here, but we know that 2 is going to be rotated, right? Because this is the rotation we're doing. And before we get rid of the 6, we want to save it in a temporary variable and move it over here, replacing the 8. But we don't want to lose the 8 yet because it needs to be rotated as well. It's going to be rotated over here to this 4. And since we rotated the 2, we know there's going to be an empty spot over here for the 4 to be placed in. And that's what you have over here, the 4. The 2 got moved over here. The 6 got moved over here. And the 8 got moved over here. So this is still a rotation. And lastly, we just have a 1 by 1. We know that, you know, it can't really, rotating it will just be the exact same. So let me show you the general algorithm to solve this problem. We're going to do this in n squared time, meaning we only have to look at each cell in the matrix once. Remember, the dimensions are n by n. And we don't need any extra memory, so the memory complexity is going to be constant. We're doing this in place in our given matrix. So I like to set some boundaries. So we know that this is our left boundary and this is our right boundary initially, because we're going to rotate the outermost layer first, right? The outermost square, and then we're going to move inward, right? We're going to do the inside of the matrix. And the top boundary I'm going to place over here because that's the top. Remember, the origin over here is 0 by 0. This position is 3 to 3. It goes like this, and as you go down, it increases. And the bottom boundary is going to be down here. So immediately we're going to start the rotation. Now, how is the rotation going to go? Well, let's start at the top left because it's the easiest, right? We know that this is the general rotation that's going to take place, right? Because we're going clockwise, and then we're going to do that, right? And we know we're going to keep doing that with every element in the top row. So we did the first element in the top row. Then we're going to rotate the second element in the top row. And how is that going to look? Well, it's going to be pretty similar. So since this was the second position in the top row, we're going to move it to the second position in the last column, right? So in this column, we're going to rotate this one to this position. So the second to last position in the bottom row. The main thing to notice, though, is that this is offset by 1. This is offset by 1 from the top. This is offset by 1 from the right. And so the position that it's moved to is also going to be offset by 1 from the bottom, which is where the last rotation took place. And then this is going to be moved over here. And so as you can see, we have one last rotation to make, right, with these 4 elements, and they actually do form a square if you tilt your head enough. This is a square rotation, a matrix rotation. But notice how, since we already rotated this one, we're actually not doing 4 rotations for the outermost layer. We're doing 4 minus 1 rotations. We're doing 3 rotations, right? So even though the outermost layer was n by n, we actually did n minus 1 rotations, right? So we did 3 rotations. And let's say after we complete the outermost layer, right? Let's say we've completely rotated that. You know, we had to rotate this part, and this part. So once we do that, then we know that we actually have an inner matrix that we have to do. So we did the outermost layer, but now we have to do the inside. How am I going to handle that? Well, it can actually just be treated as a subproblem because we know no matter what, it's going to be a square matrix. So all we really have to do is take our pointers and then shift all of them by 1. So our left pointer will be shifted here. Our right pointer will be shifted here, our top pointer will be shifted here, and our bottom pointer will be shifted here. And so now the last rotation seems pretty obvious, right? So it's going to be one rotation, it's going to include 4 elements, and then we will have our result. Now, one last thing I want to show you, and then after that rotation has taken place, we know we can update our pointers one more time. But at this point, what we'll notice is our left pointer is over here, and our right pointer is here. We know that left should always be less than right, and since these pointers have crossed each other, we know that we can stop the algorithm right. We don't really have a matrix left to rotate. One last thing I want to show you about the rotation is we know that the top left is going to be put in this position, right, the 11. So we're going to cross that out. So we're going to really replace this with a 5. But then what happens to the original 11 that was placed here? Well, what we can say is, oh, let's move the 11 to a temporary variable. And now let's put the 11 over here. So we're putting an 11 over here now. But what happened to the 16 that was over here? Well, we have to put that in a temporary variable, a 16, and then move that 16 over here. So let's replace this with a 16. But what happened with the 15 that was over here? Well, we moved that to a temporary variable. And now that temporary variable 15 is going to be placed over here. So the 15 is here, and we don't have to move the 5 to a temporary variable because look, we already put it over here. So we're needing a lot of temporary variables. I can show you a slight improvement to this, which isn't required or anything, but I think it makes writing the code easier. So we know that this 5 is going to be rotated, but let's do this.
So let's try to solve it after watching this solution. Looks like he did explain it pretty well, but let's go here, and we need top and left. So first of all we need to find row len. Row len is equal to matrix dot length, and let column len, it would be the same, right? So let's keep it as is because it's n into n matrix. Let top, what the hell is going on? Let top is equal to 0, then bottom, so my keyboard is bottom equals to row len -1, and let left is equal to 0 and right is equal to row len -1. So what we need to do is, while left is less than right, we need to continue to doing the shifting, right? So what we'll do is, matrix let temp is equal to matrix of top left top right will store in the temp, and then we'll swap matrix of let's create a function swap a comma b Okay, I'm doing something wrong here, so let's skip this. So matrix of top right with matrix of top left. I want to swap it with matrix of top left and matrix of top right. And then what we need to do is top plus plus and a top, not top plus plus, but left plus plus. And then what we gotta do is temp let temp2 is equal to matrix of so we move there, and then bottom right, then matrix of bottom right will be shifted will be replaced with temp, okay, sorry, matrix I guess we don't need to swap anything. Matrix of top right is equal to matrix of top left, yeah, and then matrix of bottom right equals to temp, then let temp3 is equal to matrix of, so what we need to do is move now right was at okay, so right, what do we need to decrement? We need to decrement here top, or right is the column, right? uh, um, So right and topmost, bottom right. I know this bottom right is there, but what do we need to increment here? Next time we need to go to the next element, right? Top is here. This is fucking irritating.
Let's do the rotation in reverse order. So instead of moving the 5 over here first, I'm going to take the 15, which we know is going to be placed over here, and I'm going to put the 15 over here, and I'm going to move the 5 to a temporary variable. Okay, so are we going to move the 5 over here now? Nope, that's not what we're going to do. We're going to do this in reverse order. So since the 15 has already been moved, let's take this 16 and move it over here. So now let's replace this 15 with a 16. And now we know that we need to make a rotation from 11 to here, so let's put an 11 over here. And last but not least, we know that the original 5 had to be put over here, and we stored that 5 in a temporary variable, so now let's move that 5 over here. And so we did the exact same rotation, but do you notice how we did it in reverse order, right? We went counterclockwise, and the thing the reason that was helpful is we only needed one temporary variable, which will make the code a little bit easier for us. But it's not actually required. The overall complexity is still the same. The memory and the time complexity is still the same. So now let's get into the code. I'm going to run our rotation while left the entire row except the last element. So how many rotations is that going to be? That's going to be from left to right minus 1. Or in other words, we can say from in range right minus left. So this is the number that we're going to do. So if left was 0, right was 3, we would do 3 minus 0, which is going to be 3 iterations, even though we have 4 values in our first row. So I also want to have some top and bottom pointers, and these are actually going to be the same as left and right. So top is going to be the same as left, and bottom is going to be the same as right, because we do have a square matrix. It's not just a generic rectangle, it's definitely a square. And the first thing I want to do is save the top left value, right? Because the way I showed you the rotation, we only need to save one variable, so it's the top left. I'm going to get that from our matrix, so matrix of top left. And just like in the drawing, what I'm going to do is move the bottom left into the top left. So in the position of the top left, I'm going to move the bottom left into that spot. The next thing I'm going to do, just like in our drawing, I'm going to move the bottom right into the bottom left. We are doing this in reverse order, basically. Even though the rotation is clockwise, the direction we're going is counterclockwise. So the bottom right is going to be moved into the bottom left. We also want to move the top right into the bottom right. So in the bottom right position, we're going to replace it with the top right. And the last thing we have to do is move the top left into the top right. But remember, we overwrote the top left position. But good thing for us, we saved it in a temporary variable. In the top right, we're going to replace it with the top left. There's just one thing we forgot to use. So we forgot to use our I variable. So you remember how this was the first rotation that we make, right? And then we move from our top left position, we move one spot to the right. From our top right position, we move one spot down. From our bottom right position, we move one spot to the left. And from our bottom left position, we move one spot up. And then we do a rotation from here, right? And then we're not done yet. From there on, we move another position to the right, another position down, another position to the left, and another position up. And then we do a rotation from these values. So we can actually handle this pretty easily in our code. We can use this I variable to handle that for us. So we can add the I value to the left index, which will shift us one position to the right. And this is also the top left position, so we're going to add I to this as well. This is the bottom left position, and we know that we can subtract I from the bottom, which will shift us up by 1. And this is that same value, so we're going to subtract an I from that as well. This is the bottom right, and to shift that to the left, we can subtract I from the right index. And this is actually this is also the bottom right, so we're going to subtract I from that as well. This is the top right, and as we continue doing rotations, we're going to move down in this column, so we're going to add I to the top index, and this is the same top right.
Okay. So R minus L.
right? So we're going to add an I to this index as well. So basically, as I is incremented, it's going to be handling more and more rotations. It's going to shift these cells that we want to rotate accordingly. And so this will basically perform a layer of rotation. So after we've completed an entire layer, what are we going to do? We actually need to do one last computation. We need to update our pointers, right? Because now we're going to do these submatrix. So our right pointer can be decremented by 1. Our left pointer can be incremented by 1. And that is the entire code. So it's going to complete every single layer. Once every layer has been completed, our loop will stop, and we are not required to return anything. Like it just says over here, we're doing this in place inside of our matrix. So we don't return anything. This code is good to go. And as you can see,
So all that we were missing was for let I equals to 0, I is less than R minus L, I plus plus. So actually need to move this code. Okay, so we moved it, and then in the end we need to do L minus equals to L plus equals to 1 and R minus equals to 1. Let's call it R. Need to call this R. Okay, my laptop is pretty shitty. Okay, so we are storing top. Okay, we are storing top right plus I, then same plus I. I'm doing it clockwise, so top would be, left would be plus I, then we would be moving the bottom right plus I plus I, and then next would be let temp 3 is equal to matrix of, then we moved from top to this to this guy, bottom left, bottom left plus 1 plus I, right, or minus I, yeah, minus I. We need to move matrix of bottom minus I left equals to temp 3 temp2, sorry, we need to move temp2 here, and now we just need to move this to matrix of top, left plus I to this guy, temp3, right? So yeah, once we do that, so this is moving to the right corner, and so from left we are storing it to right, then whatever we stored in right we are storing in the bottom right, and then the bottom right temp will be storing at the bottom left. Let's see if this runs. Oh, have I used? Okay, I guess then I need to make this left, this right, right, left, and here also right, left, and left, right. Guess right minus I, because we need to move down, and I guess for right this will remain as is, top plus I guess we have to do top plus I, not right minus I, so top will be going down, so top left. Okay, so this is good. Then bottom right I will be shifting, it will be minus I, not plus I. Yes, we have to go this way. Then bottom of I minus, so we have to go reach to the top, so bottom minus I, and left as is. Still the same. I guess I might be doing something wrong. Okay guys, I need to revisit this question again. So yeah, okay, no worries. We'll visit this question again and try to solve this. Why am I? Let top and bottom is equal to right and left. Okay, yeah, let's do it next time. This is taking me nowhere. Let's do it next time then. Okay, cool. Thanks guys. Hopefully I can solve this next time.